So we'll take a quick look at the problems on page 14 that you should have just done. So the initial value for this TV, it's valued at 1500. So A equals 1500. It depreciates, so this is a decay factor. So B equals 1 minus, again, 0.42, so 42% equals a decay rate of 0.42. So we got B is 0.58. So the function that models this thing will be 1500 times 0.58 raised to the x power, right? So x is number of years. So for this part D, we're just going to plug in x equals 2. So y equals 1500 times 0.58 raised to the second power. Go to your calculator. So we have 1500 times 0.52. Was it 52 or 58? Excuse me. 0.58, 1500. So 0.58. And we're taking it to the second power. So in 2 years, it's worth $504.60. So 504.60. So it's lost a lot of its value in 2 years. So the question now, how long is it until the TV is only worth $33? So here we're looking for what x gives us y equals 33. This is a perfect application for Desmos. So what we'll do, we'll go open up a Desmos window. Give me just a second. We're going to go y equals 1500 times 0.58 raised to the x. So how long is it going to take? So this actually was on the same window that I had earlier. So start tracing along until we get to, again, um, this is the value of the TV. And this will be number of years. So scroll along. It looks like 30 is going to be somewhere in here. There's $33.12. So I'm going to have to kind of guesstimate. So after about 7 years, according to this, right, 7 comma 33, 0.12, so just over 7 years using Desmos, we can figure that out. Again, go until the value drops down to $33, and that's about as close as I'm going to get moving this around, so just over 7 years. So it'll take about 7 years. All right. The population of killer whales has increased at a rate. So here we go, increase. Um, so you've counted 30 whales, which means A equals 30. This is a growth, so we got to do our B here is 1 plus the rate. So 8.5%, be very careful, it's 0.085. 0.085 equals 1.085. So my function here, 30 times 1.085 raised to the x power. So what will the population be after 5 years? So this is plug in 5 for x. So y equals 30 times 1.085 raised to the fifth power. Just go straight to your calculator for this one. So we have 30, 1.085, and then we're taking it 5 years out, I believe. Yep, 5 years out. So raise that to the fifth power. That tells me there'll be about 45 whales. So there can't be 45.1 whales. We'll just call it 45 whales. So there's about 45 whales. How long until it exceeds 100? So in other words, what x value goes with y equals 100? This is where you're going to want to go use Desmos. We can't just plug it in because that would give us a problem that we're not really equipped to solve right now. We can't really go solve for x up there. You guys don't have the tools. But what we can do, let's just go to Desmos and we'll kind of play around with this thing. Let me erase our TV problem. So we had y equals 30. Oh, 30. We had 1.085. And we're raising that to the x. And so the question for us, when will we get 100 whales, I believe? Yeah, so let's work along here. Here's where we're at 100 whales right there, it looks like. So it looks like it takes us about 14 and a half years. So somewhere between 14 and 15, you can see where that Y value jumps over 100. Somewhere between, 14.7 and 14.76. So let's say between 14 and 15 years. So, and again, the word approximately is here. So we're going to say it takes about 14 or 15 years. Somewhere between there, we're going to hit our 100th whale, right? They're not all born on the same day. So maybe about halfway through the year, we get our 100th whale in that group.